I mean, we are so delighted to have Dr. Patricia Ventura Garcia and Armindo de Santos Rodriguez, both from the University of Azores. They are going to chat with us about the research on the volcanoes and the impact of this type of natural events in human health. But before doing that, I would like to give you a very short and brief introduction about what this seminar series is and about what our consortium is. This seminar series is brought to you by what is a collaboration between the International Medical Geology Association and also the International Environmental Health Sciences Consortium. Many of you will ask, what is the International Environmental Health Sciences Consortium? Well, we are a group of scientists covering every corner of the world, that our mission is this consortium was put together basically the mission is to strengthen the global growth of our association, IMGA, and the discipline of medical geology. And there are two aspects that we are very much involved in trying to do that. One is on developing training and research in the area not only of medical geology, but also other traditional areas that are perhaps not as much medical geology, but also that includes participation of public health and environmental sciences and geosciences, such as occupational epidemiology, environmental epidemiology, toxicology, this kind of areas. So the consortium is focused in trying to strengthen the global impact of IMGA by providing more training and research, developing research areas or research projects in these areas. One of the aspects that we also are being focused on is on developing centers of excellence on medical geology research. And there are already a couple of centers that are going on. One of them is a development of a center on medical geology research in Nigeria to provide training for the African continent. So there is this is what our consortium is in a nutshell. That's what we actually do. And the composition, as I mentioned, we have these scientists from all over the globe. We have representatives from South America, from Chile, from Central America, from Mexico, from the US, from China, from Australia, from Italy, from France, and many others in the consortium. The consortium, one of the aspects, as I was describing in terms of training and research, is that we actually developed a program that is to bring scientists, international scientists in these areas of medical geology to talk to us about their research, how they are working on research areas that developed and impact medical geology. And today we have a great speaker with us today. We are so delighted that we have Dr. Patricia Ventura Garcia and also Armindo de Santos Rodriguez, who are going to talk to us today about the research on volcanoes and the impact to human health. Patricia and Armindo are both from the University of Azores in Portugal. Let me just tell you a little bit about Patricia, who's going to be our main speaker today. Patricia is a professor of ecotoxicology, environmental health, histology, and entomology at the University of Azores. She has been in this area of research for the last 20 years or more. She is the leader of the Island Environmental Risk and Society group at the Center for Ecology, Evolution, and Environmental Changes. She is also the deputy director of the Azorean Biodiversity Group. So you can see that Patricia holds very leadership lead groups to protect the environment and in the island of Azores. And it's a privilege for us to have her here because she must be so busy that we are privileged to have her here today. The Patricia's research area or current research areas has been focused mainly on the ecotoxicological effects of natural contaminants such as volcanogenic pollutants and anthropogenic as well from the agrochemical applications, air pollutants, emissions, and others. And all that, she directs those efforts to understand how these contaminants impact human health and other organisms such as aquatic and terrestrial organisms. For the past few years, Patricia has been involved in environmental health, medical geology, and risk assessment research in the islands, using as model the natural and urban ecosystem of the Azores. Her current research is driven by two main objectives. One is to evaluate the ecotoxicological impacts of agricultural management in volcanic islands, and a second main focus objectives to assess the environmental and human health risk in volcanically active environments. I am personally really proud and delighted that I have the opportunity to have Patricia and Minder here with us today. We know that they are very busy people, but putting aside your time to talk to us about the research means a lot to us. So with that, Patricia and Minder, thank you so much for being here with us. And we will, the floor is yours. We will be delighted to listen to your talk. And welcome.
Well, thank you very much, Jose, for your always kind and nice words. Of course, it is, I must say that the pleasure is ours, mine and Armindo's. As you know, we really embrace the IMGA project and the medical geology issues. So for us, it's really an honor and a pleasure to be present today and to share a little bit of our research with those that are assisting this seminar. I also would like to thank you and Diego for the invitation, which, as I already told you, it's really an honor for us to make the presentation. And I think I will start with my presentation, okay? So I will start to share my, I don't know the term in English, my screen, okay, my screen. Yeah. I hope you are seeing the presentation, the slides.
Yes, we are.
Okay, maybe you can. Is everything okay?
There we go. Yeah, it's everything looks fine. Yes.
Maybe I will just choose here something that it's better to point. Okay, this one. You can see my pointer? Yeah?
Yes. Yeah.
Yes. Okay. It's beyond my control. As a teacher, I have to use a pointer. Otherwise, I can't talk. Well, so today I will be talking a little bit about our research in the area of the effects of volcanic or volcanogenic pollutants in human and its effects in human health. So I've decided to give the title to this talk, the one that is presented here, Sleeping Volcanoes, Awaking Health Issues. Why the title? Because I will mostly talk you about the volcanogenic pollutants that exist in volcanic areas that are active but are not in eruptive phase. Okay, so that's what we call sleeping volcanoes or dormant volcanoes. Okay, they have volcanic activity, but it's not eruptive one. So most of the people don't have a clue about what these beauties of the nature are putting into the environment, because in fact they don't see you know, eruptions, lava, and you know, large amounts of gases being thrown into the air. We have many studies in this area, most of them developed in the Azores, not only for the respiratory system, but I have decided to focus this talk on the hazardous effects of hydrothermal emissions on the human respiratory system. Of course, although it's me that is going to talk today, all the work that you are going to see, it's not only my responsibility, it's mine, Armindo's. We are, let's say, the main leaders of our research group, but also some of the works that I'm going to present were developed by Diana Linhares, which is currently a postdoc in our working with us. She is a postdoc in medical geology. Felipe Bernardo, that is finishing his PhD, and Ricardo Camarinho, that has defended his PhD last month, so is very recently, let's say, a postdoc. Me and Armindo, we belong to the Faculty of Sciences and Technology of the University of Azores, but we work in, or we are associated to distinct research centers. As Jose told you, I am associated to the CH3C Center and to the Azorean Biodiversity Group, and Armindo is associated with the Institute of Volcanology and Geological Risks Evaluation. Having said that, I will move with the presentation. Why she's not okay? So this is our team that I have presented on the first slide. Here you can see Diana, Ricardo, and Felipe, Armindo, and me. These are some students, some of them are still working with us, others have already finished, and I couldn't resist, I'm sorry, Jose, but I couldn't resist putting here this photo that you took us in China when we were for the Congress. Me, Armindo, Jose, and Diego, as you can see, we were very happy in this photo. As a brief outline for my presentation, I will start to talk a little bit about the volcanism in the world and particularly in the Azores. And then I will move on to explain how these volcanically environments pose a risk for respiratory diseases. And this is demonstrated either with studies made with humans, or studies made with surrogate or bioindicator species. In this case, I will talk to you about with studies that have been done with wild mice. Okay. Just to talk a little bit about the main effects of air pollution. All of us, you know, we see it on the media and we hear every day that air pollution is a big issue in our planet. What you probably don't know is, according to the World Health Organization, in a paper that they have produced in 2021, in November 2021, this organization considers that about 7 million deaths occur per year only on the account of the air pollution. Mainly of these deaths are related to lung cancer, severe respiratory diseases, and cardiovascular diseases. But besides that, and also being very important, is the fact that many other respiratory diseases have been seen their incidence increasing steeply over the last years due to air pollution, such as asthma, chronic bronchitis, and many others. Okay. In this image here, this is the paper that I have told you about, the World Health Organization, published, I think this data is from November 2021. As you can see, regarding for deaths, the number of deaths regarding as a result of all sources of air pollution, it's about 7 million. It's estimated to be about 7 million. And of course, this is divided between air pollution, outdoor and indoor air pollution. There are other estimations, some higher and some lower, about this link between the air pollution and the number of deaths in our planet. But all of the numbers, as you can see, are quite concerning. Okay, so it's really an issue that we must take into account when we are thinking about human health. Regarding air pollution, most of the studies and the awareness that people have for air pollution are related with anthropogenic sources of air pollution. So most of the times we are concerning about the air pollution, that is the air pollutants that are being emitted, for instance, from industries, from manufacturing, the burning of fuel, forest fires, etc., etc. So humanity in general are more sensitive to the problems caused by anthropogenic pollution and are not so aware about the other sources of air pollutants that are natural. Of course, the anthropogenic ones, we can control. The natural, we cannot, but it's a fact that they exist and they are also very important for our health. So as main sources of natural air pollutants, we have the soil that emits into the atmosphere particulate matter, for instance. We have the natural radioactivity, which is a big issue in some areas of our planet. And of course, and I have highlighted in red because it's what is I'm going to talk about, the volcanic emissions. Okay. When we take a closer look into the volcanic activity in our planet, we have, of course, areas such as the famous Ring of Fire, and here the Mid-Atlantic ridge with the hotspots of volcanism that are really important in what regards the activity of volcanoes. It is estimated, and it's an estimation because these values are only for land volcanic activity. Underwater volcanic activity, it's a lot more difficult to be calculated. It is estimated that we have almost 1,500 active volcanoes all around the world. And among these, about 500 we have registered historic records of their volcanic activity. And among these 500, about 40 to 70, depends on the years, of these volcanoes have eruptions in our planet. So as you can see, although we only hear sometimes in the news about, as it is the case of Cumbre Viejo now in La Palma, we hear about these eruptions. There are a lot of active volcanoes in our planet, and if they are active, even though they are not eruptive, they are releasing into the surrounding environments a lot of material that can be noxious to our health. In this slide here, I have highlighted the position of the Azers that I will talk a little bit further ahead. but as you can see, it is situated in the triple junction of the North American plate, Eurasian plate, and African plate. So this is the reason why this is a seismic and a volcanic activity occurs in our islands. Okay, just to show a little bit how impressive the eruptive phases of volcanoes can be to the community in general, to the human population, and how we can easily see if they are releasing these hazardous elements into the environment. I bring you as an example the eruption of this volcano in Mount Pinatubo, Philippines in 1991. Because for this volcano, the amount of contaminants that were released into the environment, it was quantified. You can see that, for instance, just in 2 days, 20 elevated to 6 tons of sulfur dioxide were released into the atmosphere, and during its period of eruption, it's everything in the order of tons. So I won't read it. That there were tons of zinc, copper, cadmium, lead, nickel, chromium, and mercury. And among these elements that you see here, mercury, chromium, lead, cadmium are highly toxic for the humans. They were daily released in a daily basis into the atmosphere. So this is the reason why eruptive volcanoes are more impacting as when it comes in the problems related to human health. In this table here, and the next one that I will show you, that was taken from this book, that the reference that I have here presented below, there is a brief description of the main hazardous materials that are released by active volcanoes, either during eruptive phases or during their sleeping or dormant or quiescent, if I want to use a more technical word, phases of their activity. So as you can see, besides volcanic bombs, ash, tephra, the acid rain that is produced a lot amount of gases and particle emissions are also released into the environment. But this gas and particulate matter that is emitted into the atmosphere occurs not only, as you will see, not only during the eruptive phases of volcanoes, but also in the surrounding areas or in the areas of volcanoes that are considered to be active. So if they are active, they are producing something, and if they are producing something, this something must be released into the environment. So most of the times it's released into the environment, hydrogen fluoride, carbon dioxide, sulfur, hydrogen sulfide, radon, and many other hazardous components. Okay. So I will start a little bit to talk about the sunny side of volcanism in the Azores, because I don't want to frighten you all. I want you to come to the Azores. This is a very beautiful place to live and to visit. And then I will talk to you about the hazardous aspects of living in these areas. For those who don't know, the Azores, as I told you, are placed in the Middle Atlantic ridge between America and Africa and Europe, and it's an archipelago that is formed by 9 islands, and the main one, this is the one I'm highlighting here, São Miguel, is in fact the one that has 4 volcanic systems that are active. Other islands also have active manifestations of volcanism, but São Miguel is in fact the one with most representative active volcanism. So our studies are developed in São Miguel Island, as you will see. Here you have an image of the island of São Miguel, and I think this is the caldera of Sete Cidades, which is one of the complex of volcanic complexes of systems of our islands, the Sete Cidades volcano. Then we have the system, the active system of visceral volcanic system of Picos, Fogo volcano, and then Furnas volcano, which is the system where we have been developing most of our studies. And this has a very important reason why, because in Furnas volcano, in fact, hydrothermal manifestations of volcanisms are really active, and there is a population that lives inside the volcano caldera, so they are continuously exposed to this type of emissions. Okay, so here you can see again the island of São Miguel. This is the Sete Cidades volcanic system. Here the Picos, here the Fogo, and here you can see the Furnas volcano. In this image, this square that you have here, you have the Furnas Lake. People live here, as you can see, the Furnas village inside the crater. So this, what I'm surrounding here, it's the crater of the volcano. And in this image, you have highlighted the main manifestations of volcanic activity that you can find inside this caldera, such as the fumaroles, the thermal and cold springs, steam vents, areas of soil diffuse degassing, and so on. Okay. Here you can see some images of these manifestations of volcanic activity that we can find inside the caldera of Furnas volcano. You have here fumaroles, hot springs, soil diffuse degasification, and aqui fumaroles and soil diffuse degasification. So as you can see, this is not smog. Okay, this is the sorry, I can't tell it in English now. The soil diffuse degasification that is being released from the soils, and you can see that the houses, people live very nearby, and they are continuously exposed to these gaseous emissions from the soil. One of the sunny sides of this type of volcanism is that, in fact, the emissions by the volcanoes, they have high inputs of nutrients into the soil. So we have soils that are nutrient enriched, and this is good for of course the agriculture. This produces beautiful landscapes. We have unique ways of doing cooking in the soil, in the soil that is heated by the volcanic activity. And of course we have also, this is the good side of the active volcanism, is that we have waters with medicinal properties and for relaxing purposes, as you can see here in this slide. Now talking a little bit about the dark side. So in this point, I will talk about what type of hazardous materials are being released by this type of volcanic activity, and particularly for the Furnas volcano, for the reasons that I have already explained, because we have a population about 1,500 people living inside the caldera. It is a very large caldera, as you can see, with the basal diameter over 10 kilometers. And the last eruption of this volcano was, I'm sorry, I think I had it here, but I think, okay, in 1,600, in the year of 1,630. So it's an historical eruption. In this furnace caldera, because the population is inside the caldera, and you have, so you can see you have mountains surrounding these areas of active volcanism, where the gases are released, where the water vapor, the carbon dioxide, everything is being released into the environment. It condenses, okay, it stays in this large hole that is the volcano caldera, producing a smog similar to what occurs in Hawaii, that it's called VOG. VOG, it's volcanic smog, okay? And this is the volcanic smog that has all these hazardous components that we inhale, and somehow by inhalation, and not only by that via, enter our system and have and may have some hazardous effects in our health, okay? So as I told you, although in quiescent phase or dormant or sleeping phase, this volcano, the furnace volcano, is emitting on a daily basis into the atmosphere several hazardous metals. I have highlighted in red the most hazardous ones, which is cadmium, mercury, and lead, okay? And several gases that are known also to affect our health, such as carbon dioxide, hydrogen chloride, hydrogen fluoride, sulfur, hydrogen sulfide, and again, highlighted one of the most dangerous one, which is radon, okay? That is being emitted only by the soil diffuse degassing and the fumarolic discharges, okay? We know that in the Furnas volcano, there are two villages, one that is really inside the caldera, which is the Furnas village, and another one that is Ribeira Quente, that is in the lateral slope of the volcano. We know that the majority of the houses where people, of the buildings where people live, are built on these areas of volcanic activity. We call it hydrothermal soil diffuse degassing areas, as you can see. Okay, so for Furnas, it's we know that 58% of the houses are built over these fields, and in Ribeira Quente, it is a little bit more severe. The scenario, it's almost 100% of the houses are built over these soil degassing areas. There are several studies made by the geologists, namely from IVAR, that has characterized this. This is a very well, in terms of geology, I think, I hope I'm not saying a mistake, volcano. They know that, for instance, only in a daily basis, this volcano releases about almost 1,000 tons of carbon dioxide into the atmosphere. I'm saying daily, okay? And we know that along with this carbon dioxide, there are also the other gases, because carbon dioxide functions as a carrier for other hazardous gases, such as radon, okay? So it's kind of a proxy to evaluate also the danger of the amounts of radon that are being released into the environment. And there are several studies that regard the levels of I've measured the levels of radon, not only indoors, but also indoors. In these values, I must say this, that the values that I'm presenting here are outdoor levels, okay? So they are, of course, much higher than indoor values, but they are really large amounts of radon in the surroundings, in the environment of inside the Furnas caldera. Okay, so taking into consideration that there is radon, there is heavy metals, there is carbon dioxide, hydrogen sulfides, whatever. Many of these substances are being released into the environment in a daily basis in this volcano and all the other quiescent volcanoes all around the world. Our group has been mainly focusing the research in trying to understand how this environment in fact poses a risk factor for human health. Okay, for that we have done studies either with humans, with human population, or using surrogate species, such as the case of wild mice that I will talk a little bit further ahead. So the first studies that I'm going to present you are done with humans. And of course, as I have promised you, I will only talk about the studies that regard the respiratory system or respiratory health issues related. Okay. So this paper that I am presenting here, it's one of the papers that we have done. It's a biomonitoring study. We have analyzed the levels of DNA damage in the oral epithelial of individuals that live in this case was in Ribeira Quente, not Furnas, that are chronically exposed to indoor radon, okay, in this hydrothermal area. In this study, we wanted to understand if the exposure to indoor radon in a hydrothermal area is in fact a risk factor for a cytogenetic damage. Why is this important? Because if it is a risk factor for cytogenetic damage, then is a risk factor for the development of cancer. So it's a carcinogenic risk factor. Okay, we can call it this way. Okay, so in this study, and just to explain, because I believe that not all of you are in the area of biology, so probably won't understand very much what I will say technically. So I'll try to explain a little bit how the procedure of the work was done. We have collected samples from the oral mucosa of the individuals by scrubbing the mucosa, and then remove the surface layer of this epithelia, and analyzed these cells under the microscope to see if there were nuclear anomalies. Okay, the main nuclear anomaly that we were looking is the presence of micronucleated cells, and this, you have here a good image of an epithelial cell with micronuclei, which is a cell that has the main nucleus and then a small nucleus, and this is an indication that something went wrong when this cell was dividing. Okay, and so it's usually the result of genotoxic components or substance, that is, substance that affect the nuclear material of the cells when they are dividing. Okay, so they are genotoxic. Okay, but this type of errors occur normally in the population. So there is a baseline frequency for micronucleated cells in the human population that is very well characterized in the last years. And we know that if we are not subjected to genotoxic substances, we are expected to find a frequency between 0.3 and 1.7 micronucleated cells in each 1,000 cells that we observe. Okay, so if we are within this range, everything is okay. As I told you, the study was developed in Ribeira Quente, and just to show you the scenario of Ribeira Quente, there is here a risk map for the activity of the susceptibility to radon exposure. This was made by Catarina Silva, so the study of her PhD, and as you can see, it's almost everything red. Okay, only a few points are yellow. So this means that every houses that are here are built in soils where they are degassing and releasing very actively into the environment high levels of radon. Of course, I recall these are outdoor values. Okay, indoor levels according to our regional decree, people, the upper limit of safety is about 150 becquerel for cubic meter. And as you can see here in the outdoors, the levels go higher than 2,500, so dissipates in the air, okay? In this study, we had, of course, to analyze the presence of other factors that could be contributing to the higher levels of genotoxicity, such as if people smoked, their age, if they consumed alcohol, and so on. So this is kind of a pro forma that we do in this type of studies. Then we collected the cells from the oral mucosa. They were stained, they were observed under the microscope, and then we have counted the number of micronucleated cells or cells with other nuclear anomalies. I just put this table here because this is the characterization of the population that we have studied. The exposed group is Ribeira Quente. Ponta Delgada functioned as a reference group, not exposed to this volcanic activity. And as you can see, this is why I've highlighted in red, and these are indoor radon levels, okay, indoor radon levels. As you can see, the maximum value that we had inside the houses that we have measured in Ponta Delgada is 56, but in Ribeira Quente we had much higher levels, and including reaching this one of the houses reached about 800 becquerels for cubic meter, which is much more than the upper limit, the upper safety limit that our legislation and use legislation imposes. Okay. So as results, we could see, and I only ask you to take a look at the graphic on your left. Here I have put in red the cut point. This is what the upper level of micronucleates, of number of micronucleated cells that is within the normal range. Okay, so as you can see in the reference group, the vast majority was below this level, while in the group exposed or people from Ribeira Quente, the value was more than 50% was above than this cut point. Okay, so here they have an average of micronucleated cells of 3.1. Okay, almost twice than what is considered the normal range. Okay. Also, I think told you in the beginning of the study, this study did not only evaluate the micronucleated cells, but we were also looking for genetic markers that could indicate that specific genetic alterations or mutations were occurring in the genome of these individuals. We have worked with three markers, and the F12, which is the one that I have present here, the results. In fact, for some of the bands that in this type of approach we analyze, in some of the bands, there were in fact really differences between the study group and the reference one. So this marker, it turned out to be a good marker for genomic alterations due to the exposure to this type of environment. Okay. So to wrap up the results of this study, what I wanted to tell you at the end is that in fact that individuals that were living or that are living in this area, according to this study, they have almost twice, in fact, to be correct, 1.7, their risk increased to develop genotoxic events in their buccal cells. And as we know, these genotoxic events are also linked with the increased risk to develop cancer. So in other words, we can say that these individuals, by living in these areas, they have an increased risk of developing cancer, particularly for the airways, than individuals that do not live in these hydrothermal areas. Okay. Another study that was done with the human population was a study that pretended to evaluate if living in these areas affects the human pulmonary function. This means we wanted to evaluate if living in this area we have some type of diseases or some type of impairments in our lung function that result from the exposure to these environments. To do this study, okay, we have worked with two populations, again, one from Ribeira Quente, the study group, and one from Ponta Delgada, which we have considered as the reference group. We have applied a standard questionnaire, but to assess the lung function, we have performed spirometric tests, okay? According to the American Lung or Thoracic Society parameters, we have done the tests, and we have tested and analyzed if people had either normal lung function or if they have restrictive defects or obstructive pulmonary defects or diseases, okay? For the most severe scenario, that is for obstructive pulmonary diseases, then we classified the outputs as mild obstructive, moderate, severe, and very severe. We have parallel characterized the soil degassing structures in these areas. So we measured the CO2 soil flux in these areas, because I have told you that the CO2 soil flux functions as a proxy for also the releases of other contaminants into the air. Okay. As main results here, you can see in purple, it's the population from Ribeira Quente, and in blue from Ponta Delgada. So in Ponta Delgada, there are a lot more, the prevalence of normal outputs, it's much higher, contrarily to the prevalence of restrictive or obstructive outputs that are much higher in the study groups, okay? As you can see here, I will not go into many details of the statistics because not to bother you now, okay? What is very interesting is that when we pick this group here only for the obstructive diseases, COPT means chronic obstructive pulmonary diseases, okay? When we pick the COPT cases and divide these cases in mild, moderate, severe, and very severe, we can see that the scenario tends to aggravate in the exposed group, in the group that lives in the volcanic area. That is, if we consider mild chronic obstructive diseases, there are no differences. But then if we go to moderate, severe, and very severe, in fact, very severe cases were only found in Ribeira Quente inhabitants. In Ponta Delgada, we didn't have, okay? So this really clearly shows that the lungs of those individuals are somehow being affected by the exposure to these environments, okay? So in brief, our spirometric tests told us that there is a higher prevalence of restrictive and obstructive impairments in the individuals that live in Ribeira Quente. And when we look closer for the COPT impairment, there is an exacerbation that is 4 times or 4-fold higher in the individuals that live here in red, that live in Ribeira Quente when compared to Ponta Delgada. Okay, so these were regarding the respiratory health effects or hazards that were done with humans. We have more, but these were, let's say, the most relevant ones that we had done recently. But because of this last study, that we clearly saw that something was going on in the lungs of those individuals, because the prevalence of COPT was really higher in the individuals living in Ribeira-Quente, we wanted or chose to try to understand how, in fact, lungs respond in vivo, okay, to these extreme environments. So we went on to go to study the lungs itself. Of course, to do that, and because it is in vivo, we cannot do with humans, okay? And to do that, we moved our studies using surrogate species or bioindicator species, in this case, the small wild mice, musculus. And why did we choose the wild mice? Because in fact, they share their habitats with humans. They are also exposed to these volcanic emissions. And since we are capturing wild species, okay, they in fact reflect the environment they are, the mixture of contaminants and hazardous contaminants that they are exposed. The effects reflect more accurately that exposure than, of course, only testing this contaminant or that in under laboratorial conditions. Okay. So the first work that I am going to show you went on analyzing the effects of this active volcanism in the bronchioles of the lungs. So volcanism and bronchial alterations. And as you can see here, I will very briefly, now I'm going to be more shorter in the explanation of the results. In this study, here you can see on the left side a lung of mice from a raptpeixe. We have worked as humans, we have worked with a population that is exposed to volcanism, in this case from Furnas, and another population of wild mice not exposed to this environment. So on the left side, you have lungs, an image of the lungs of a bronchial and alveoli of mice from raptpeixe. And here, as you can see, the all alveolar structure of the lungs is really in a bad shape. Okay, these are the lungs of mice from Furnas. In white arrows, you can see it is signalated the the amount of leukocytes that are surrounding the bronchioles. So it represents peribronchial inflammation, and in red, the amount of fibers that in fact are more developed or more represented in the lungs of these mice. Also, another important aspect is that the epithelia, in the thickness of the epithelia of the bronchioles in these mice, it's much more higher or thicker when compared to the lungs of mice from Ponta Delgada. So we have focused on several histological parameters, such as the thickness of the bronchial epithelia, the thickness of the bronchial submucosa, which is the fibers I was talking to you about, the presence of smooth muscle, and so on, and everything in all of them. They were more representative, the effects were more marked in the individuals that are exposed to the active volcanic environment. Okay, and of course here the same for the peribronchial inflammation. What I want to tell you is that all of these histological markers that we are analyzing here, they are consistent, the alterations that we are observing, they are consistent with the development of asthma and chronic bronchitis. So somehow they are explaining what's going on with the results that we have observed with the human population. Okay. The other study is done. It's very similar to this one, but now we have focused only on the alveoli. Okay, the other one was the bronchioles and the terminal bronchioles, and here is for the alveoli of the mice. To analyze the lung injury at the level of the alveoli, we have made several measures. Mainly, we have measured, for instance, the thickness of the septa, the perimeter of the alveoli, and so on. And in function of these aspects, we have calculated, I must say invented, created, what we called lung structural functionality ratio, that somehow combining all these measurements allowed us to see if the alveoli were in a better shape or worse shape, functioning badly or functioning good. And also we have analyzed the presence of metals inside the cells of the alveoli by autometallography methods and the inflammatory status of the alveoli. Okay, so this is what I was telling you. We have measured several histological parameters. We have determined a lung functionality ratio. We have analyzed the inflammatory status, and this is made by making a score, dividing with almost no inflammation, small inflammation, significant inflammation, and severe inflammation. And we measured the metals by making a similar scoring methodology. Okay, as results, and I will just call your attention for the combination of these three parameters in the lung functionality ratio, which is this graphic here. As you can see, the lung functionality ratio in the mice from Furnas is much, much lower than those mice from a forest, let's say almost a pristine area, okay, that are not exposed to any types of contaminants. And here, I forgot to tell that in this case, we used mice also from an area with more anthropogenic activity. Okay, so somehow it's in the middle of the situation. Here you can see some images of the lungs. On the left, from the mice from the control site, on the right, the mice from the volcanic site. And again, the scenario in the volcanic site is really aggravated. You can see here a huge infiltration of leukocytes, the thickness of the epithelia, and here is signalated these small dots that you can see here is the amounts of black silver deposits, so metallic deposits in the lungs tissues. Okay. In these graphics, you can see that the level of inflammation is much higher. In the dark columns are the higher levels of scores for either for inflammation or black silver deposits. So you can see the scenario is more aggravated again in the volcanogenic when compared to the other sites, either for inflammatory status or amounts of black silver deposits. Wrapping this up, okay, we can see that in mice caught in Furnas, there was a decrease on the alveolar space and alveolar perimeter. There was an increase on their alveolar septal thickness, inflammatory status, and amount of black deposits, which results in a lower, much lower lung functionality ratio. Of course, this lung functionality ratio translates or tries to explain that these mice have a reduced breathing efficacy because their pulmonary elasticity, the volume of the alveoli is smaller, and the air intake and the renewal of air, of course, can be compromised. Okay. Another work that we have done is, okay, we can see that in the lungs there are more inflammation in the lungs of the mice living in Furnas. So we try to see how this could happen, if in fact the tissues are responding to this, the presence of these contaminants by, for instance, producing reactive oxygen species, which what we call oxidative stress, or simply by increasing the number of cells that tends to die sooner, what we call apoptosis, okay? In brief. So in this study, we have, again, this is to evaluate the level of apoptosis or the level of oxidative stress. It was, the approach was similar than to the previous one. So we scored, okay, we have 4 levels, 1, nothing, 2, somehow, 3, medium, 4, it's happening, and it's happening in a heavy way, okay? So as you can see again, in Furnas, okay, for the level of oxidative stress, you have higher levels of 3 and 4, and for the amount of apoptotic cells, again, in Furnas, it is much more elevated than in the mice from Raptopeixe. In this study, we also used mice from Ribeira Quente, and as you can see, there are, in the case of oxidative stress, there are no differences from Furnas. In the case of apoptotic, the level is a little bit higher of apoptotic cells is a little bit higher in mice from Furnas when compared to Ribeira Quente. And this can be explained by the fact that they are inside of a large hole. Okay, so there is no air renewal inside the cratera, the Furnas caldera. Okay, so here you have some images. I'll just move forward from them very rapidly. Here you can see these spots that are marked with the black arrows represent the oxidative stress. So again, on the right, lungs from volcanic, on the left, lungs from mice from the reference group. Okay, so you can see that there is a large amount of leukocytes in gray and a higher amount of oxidative stress. In green, in bright green, you can see the cells that are apoptotic. So again, you can see that in the volcanic area, there are a much higher level of apoptosis. And in the last slide, you can see here it is marked the presence of macrophage here, these small arrows and the of leukocytes. Okay, why I'm showing this? Because this last observation led us to take the next step, which is the final work with the lungs of mice that I will show you, that is to try to understand if the increase of macrophage in the lung tissue somehow is kind of entering a loop resulting from the exposure that leads to an exacerbation of the inflammatory process, the production of more fibers, and then reduction of the elasticity of the lungs, which in turn again promotes the recruitment of leukocytes and taking this loop further ahead to produce pro-inflammatory cytokines, which is the case of TNF-alpha, that increases the whole inflammatory process, resulting in those lungs that are so in so bad shape that I have shown you in the previous slides. Okay, so in this work, in fact, we observed that. Okay, And we observed that the amount of macrophage was increased in the mice from Furnas. We observed that the amount of leukocytes, the recruitment of leukocytes to these lungs was also more significant in the mice from Furnas. And we have observed that the alterations in the alveoli or in the lung tissue in these mice were consistent with pulmonary emphysema in these mice, and this was also more relevant and highlighted in the mice from Furnas. So all of these results, in sum, have shown that the things that are happening in the lungs of these mice that regard the recruitment of leukocytes, the increase of macrophage, the production of pro-inflammatory cytokines, which is the case of 10-alpha, which is this graphic here. All of these alterations that make the septa thicker, the volume of the alveoli smaller, all of this result and are consistent with pulmonary emphysema and result or explain the more severe scenarios that we have observed in the humans regarding chronic obstructive pulmonary diseases. So we now understand why, in fact, in this population, the level of severity of COPD was much higher in the Furnas individuals when compared with, in the case of humans, when compared with those from the reference group. Okay. Just to finalize, okay, I couldn't resist to show you one of our latest works because it's going to open a new line, as it has already opened. From this one, we have already 4 more papers, but I will not discuss it today. It is the importance of some chemical elements, and this is the case of volcanic gaseous elemental mercury, that according to the geologists that have measured the what we call GEM, which is gaseous elemental mercury symbology, it is almost insignificant in Furnas. But in fact, it's insignificant, but it's in the air that we inhalate. And what we have saw with this short communication is that this gaseous mercury was uptaken into our lungs, okay, when was significantly uptaken in the mice that live in Furnas, okay? So you can see here in this slide, on the right, the lungs from the reference group, on the left, the lungs from Furnas mice, and you can see with the black arrows, okay, you can see pinpointed the deposits of this elemental mercury in the lung tissues. And we know, not only from the bibliography, but also from other studies that we have already done, that this mercury can cross the blood-brain barrier and is found inside our brain tissue, white matter in the spinal cord, or in some neurons, whatever, okay? It's fine in the blood vessels inside the brain, okay? We can find this mercury, these deposits, okay, in the individuals that are living in Furnas. And as we know, mercury is an element that is what we call neurotoxic. So it means that it causes problems, neurological problems in the individuals, okay? So what we want to go on now is to see if the populations that are exposed to this type of environment, and of course to GEM. Gaseous elemental mercury, it's the main form of mercury that is released by the volcanoes into the atmosphere. If somehow they are at higher risk of developing neurodegenerative diseases such as Alzheimer and Parkinson, because we know from the research that these diseases are now well recognized as being linked also to many factors of exposure in the environment, and this might be one of them. Okay, so although far less studied than anthropogenic pollution, non-eruptive volcanism is clearly affecting the lungs in the organisms that live in these areas, and including the humans. So it's something that we must not disregard, we must monitor, we must be with attention to those populations, because in fact they must be followed up by clinicals, because this environment really has some hazardous impacts on their respiratory system. So I would like to thank you all for your attention and hope to see you someday here in the Azores, and maybe, who knows, in our university. And that's it. If you have questions.
Thank you, Dr.
I
Patricia.
think I will stop sharing, okay?
Yep. Thank you, Patricia. This is remarkable research. I mean, it's. I'm so glad that you were able to share this with us, because it shows something amazing, how you can actually connect the human studies also with the in vivo studies as well, and see a correlation with those studies. I'm very, I mean, when you looked at the increase in the risk of cancer by looking at the micronucleides, and then you see also an increase in COPD from those human studies. That's an amazing way of looking at the data, and looking also at the animal data. One suggestion that I would like to consider would be, I don't know if you have been able to look at registries in the islands of the Azores and see if those registries may provide some retrospective, information, morphological information, pathological information about, let's say, foreign materials that may be lodged into the lungs of patients that may have been exposed or lived in those areas. That will give even more support to your outstanding research, because I think that that's the way in which we can connect also the current way in which we look at exposure with the past markers that we can look in pathology. I like your observation that you have on the increase, the last few work on the increase of macrophages, and then the effect of that. One area that I'm very much interested is in looking not only at macrophages but also granulomas that may be developed as a result of foreign materials that may be lodged into the lung. That's an area that I will suggest also for you to consider looking into those animal tissues and see if there's granulomas that, the increased cell size that may be present. So overall, this was outstanding, and I just glad that I'm delighted and honored that you gave us the opportunity to listen to you and to see this remarkable research.
Thank you, Jose, for your nice words again. I will try to explain a little bit about. I think you were talking about previous studies with epidemiological approaches, right?
Right,
okay.
right.
Okay. So regarding the sorry, the term in English, regarding the cancer, okay, we have, in fact, all of these studies that we have been done appeared because of previous studies that were done by Armindo, and maybe he wants to talk a little bit about that, and a previous PhD student that we had, André Amaral, I think in 2006, right, Armindo?
Yes, in 2007. Yes.
2007, yeah. And they have, André had some knowledge on the epidemiology area. So he went to the records that we had on the hospitals and tried to analyze the prevalence of and the incidence rates of some types of cancer in the human population. And for that, he studied Furnas, he compared Furnas with individuals from Santa Maria, which is the oldest island of our archipelago, non-volcanic, well, without zero volcanic activity since ever, and more or less it's volcanic, of course, but without volcanic activity. And he compared, and in fact he found some differences in the lip and oral, for instance, type of cancers. This is why we started the first studies that we have done were with biomarkers of genotoxicity, the micronuclei, not only that one that we showed, which is a more recent study because we have used other molecular markers, but the previous one, I didn't talk about it, was done in 2012, and just to confirm, in fact, what the epidemiological data were showing us. For the respiratory impairments, let's say, for instance, COPD, okay? We would like much to, in fact, have access to this type of data. The issue here is, since, let's say, the last 15, 20 years, it's being really difficult to have access to that type of data, okay? Even for when you have clinicals associated with us, because of data protection and so on, it's not so easy to gather that information, okay? Because it would be nice to have a record for the last, let's say, 20 years, right? And see if, in fact, this is a consistent all over problem all over the periods. Maybe we are still trying. So when we have the opportunity to incorporate the clinic in our project and try to have access to that data, we always try to do that. And until now, it's not been easy. Okay, so we don't have, in fact, data from the epidemiological data to share, other than the ones that we have measured. I don't know if Armindo wants to tell something.
No, you tell everything.
I'll tell everything. I'm sorry. I will let you speak the next time.
I have to go in a few minutes, but I have a question. And first of all, very good, so excellent. I learned a lot, Patricia. Thank you. I suspect it's not easy, but is there any information on the change in health of people moving into this area as well as people moving out of the area? I know this is probably a state.
That's a very good question. Well, no, we don't have that information, but it could be something to, if it's not easy to design that type of study, because of two reasons, okay? One is Furnas, it's not such a large population. We are talking about 1,500 people, okay? So they don't move so much. They live there. So that's why they are also a good model, because they live there since ever, okay? And that's why this is a chronic exposure, not an acute one. We have a study, and I will pass the word to Armindo, we have done a study only with acute exposition, okay, from individuals that go and visit furnace and stay there and are exposed and so on. And then when they got out of furnace. I don't know, Armindo, if you want to talk about that?
We use a group of, we use the group of students of our university, 20 students, I think, and we studied them here in Ponta Delgada, and then we exposed them for half an hour to the calderas, and then we measured some parameters such as metals in urine, oximetry, and respiratory parameters also. Mm-hmm. And they don't vary very much, but because it was only an acute exposition, you know. Mm-hmm. When you have a chronic exposure, I think it is expectable that we have much higher difference between different groups. We compare in the past, in a study that we have done, men from a group of men from different ages, from furnace that were live there from the entire life, since children to elderly, and also with a group from Santa Maria. And we compare hair samples, and we analyzed them, and for all the metals, almost all the metals that we analyzed, men from furnace showed very higher concentrations of metals than men from Santa Maria. That's what we have. But I think acute exposure is not easy to study with human people.
Yeah, but Bob, what you were saying, because if I understood what you were asking, if that there is a possibility for those that are chronically exposed and then removed from the environment to the lungs to have some type of recovery, right?
Yes.
If they have coughed, no. Coughed, usually it's non-reversible. But if they have restrictive impairments, yes, maybe they could recover. Okay, so to do that, I think with humans, it's not easy because you don't have the large enough samples or n replications, you know, to give, you know, statistical support to your conclusions. But maybe we could do it. Maybe we could do it with mice. I don't know. The problem is that we cannot easily evaluate the lung function by spirometry in mice. It's crazy. Okay. But that's a good idea. We will see if there is some type of design that maybe we could show that this process, at least in the less severe ones, can be somehow reversed if people are removed from the environment. I don't know if the real estates in Furna will like that, but okay. We'll try to manage that diplomatically.
Thank you again, and I have to run, but excellent presentation, and I look forward to the next one.
Thank you, Bob.
Bob, me too.
Any other questions for Priscilla, for Patricia? Remember, if you don't, if later on you come up with a question, also Patricia Armindo will be delighted to receive your emails as well and answer any additional information that you would like to have. I also think, Patricia Armindo, that this is a far-reaching information and seminar, because people in other places around the globe where this issue of volcanoes are affecting the local population can easily adapt these studies that you have conducted to their areas. So I think that this will have a more far-reaching impact for those areas that today we see very active, volcanology activities. Any questions? Any additional questions?
I think Luis.
Luis?
But he has to unmute. You have to unmute Luis. He's talking, but
I cannot see. Jesus, can you see that?
Luis
Yes, Dr. Luis Colmenero. Doctor Colmenero.
Luis, no le oímos. Tienes que conectar el
no
micrófono.
Ahí está.
Ahora sí.
Listo. Gracias.
Sí, ahora
Thank
sí.
you. Go ahead.
The radium values is not very important, is not high. Do you have values about doses for people?
You are asking about the biological doses?
Doses?
Or effective doses in the individuals?
Sievert, millisievert?
Sim, Sievert, I understand. No, in the human, acho que não, pois não, Armindo, não temos medições nos humanos, no.
No. They use not a dosimeter. We perform work in the hospital, but in the furnace population, we did not.
We have for other type of exposures, but not the in furnace inhabitants, no. But that would be something that maybe we should do someday and try to correlate those data with the values that we have observed, because it's more
accurate,
fine-tuned per person. Yeah.
Yes. In lung, the damage for radon or other opposite is different.
Yeah.
Different. Do you have the difference in radon or the other contaminant?
If we can separate if it is only radon or if are the other contaminants that are doing the damage, that's your question.
Yes, the damage is different.
Yes, of course.
For instance, when you see in the lungs, most of the inflammatory processes and things that I have shown, most of it are related to probably, and that's why we have estimated the amount of metals inside the lungs, is related with the presence of metals, of hazardous metals. We don't know which, because the technique didn't allow us to say we have an idea which probably they are, but we didn't quantify each of them. But that type of anomalies, that type of problems is more related with the presence of metals. When we are looking for the genotoxicity damage or genotoxic damage, of course, some metals, also may pose this problem, but I'm more certain that the bigger part or the larger amount of genotoxicity is caused by radon because of the radioactivity. And this clearly hits the DNA and then causes these damages in the DNA. So the studies regarding the biomarkers with micronuclei, although some other components may be contributing to this damage, I think the main one is definitely the radon. And then when we did the risk analysis and at the input of radon exposure, but not directly in humans, as you asked, but in the environment, we had very good correlations, and really it was the risk factor that popped out from the analysis.
Okay, thank you.
Patricia, I got a comment from a colleague asking about if you have done any work or have seen any issues dealing with arsenic in the population that has been exposed.
No.
I suppose that my colleague was looking more about the drinking water, because that might be a confounding factor for the biological effects that you have seen. So I don't know if I just got the question from my colleague.
No. I think I will ask here a little bit of help to Armindo. Armindo, I think we don't have such high levels of arsenic, right?
No, in the tap water, the analysis that we know, they have not values of concern.
Yeah.
Okay.
So they are lower than the level, admissible level by the law. So
here
but volcanic water, for instance, for thermalism, they have higher levels of arsenic. That's why, for instance, in furnace, to open an auto, it lives several months until they have the levels that the law obliged.
Interesting. Oh, very good. Okay.
Yeah.
Oh, interesting. Any additional questions for Patricia and Armindo? Well, I want to first let everyone know that this presentation, as well as the others that we have had for our speakers, they will be available in our Facebook and YouTube channel for everyone to see again and to study more. And also these presentations can be downloaded for educational purposes, of course, upon the proper approval by the speaker and the consortium and the association, the IMGA. They will be both in the IMGA website as well as the consortium website. Then also I want to take the opportunity to give you some announcements. First, one is that tomorrow we will have another, IMGA is going to have another presentation by Professor Xiaoshan Chen. He's going to, from the National University of Ireland, and Xiaoshan is going to entertain us and talk to us about his photography and how that can be used for well-being in our lives. So I think it's a great opportunity to see excellent photography, and it's going to be at 13 hours GM time of Dublin. So Diego can tell you a little bit more about that. I would also like to mention to you about the Jesus, if you can put the announcement for the MedGeo. It's for MedGeo 2023. Our conference of the International Medical Geology Association will be in Monterrey, Mexico in 2023. And we have Diego, Jesus, and other colleagues from Chihuahua that could actually talk to you more about that. And also I want to let you know that we are going to continue with this seminar series of the IMGA and the International Environmental Health Sciences Consortium. And we have we are delighted because we will have the opportunity to continue with this topic in our upcoming seminar, which is probably in February. And our next speaker, we are talking to Claire. Claire Howard has accepted our invitation to be our next speaker And we are delighted that Claire is here on this seminar with us. So I would like to ask Diego and anyone that, if you can, if you would like to say something about these announcements and also about the association.
Thank you,
Diego?
Jose. Well, thank you very much, Patricia and Armindo, for the presentation. It was a great presentation, amazing. And I think, as Jose said, that the methodology that you developed for this kind of study can be adapted or reproduced in other scenarios, in other countries. So it's very, very important for our community as IMGA to have all this information available in our webpage. So thank you very much. And thank you, Jose and Jesus, for all the work that you are doing with us.
Thanks, Diego.
Thank you.
Anyone, Jesus, or you would like to say anything about the MetGeo 2023?
Okay, thank you. I really appreciate it. And congratulations for Dr. Patricia and Dr. Armindo for your presentation. It's very clear, very brilliant. And well, welcome to Mexico in 2023 in Monterrey for MetGeo. Mexico is your house for everybody. Thank you.
Luis, you're on the organizing committee. You would like to say something about the conference, the 2023 MetGeo?
Maybe about radioactivity, I would like to presentation. In Chihuahua, there are many uranium sites and many radioactivity. Too much. We have the most doses in radon for Mexico country. I would like a presentation that.
Good. Thanks, Luis. Well, I would like to thank Patricia and Armindo for an excellent presentation, for giving us your time. I know that you guys are extremely busy working on in your university and with your programs. We are grateful for your time. We are grateful for continuing expanding the field of medical geology. I very much look forward to see you either in Azores or at MetGeo 2023. So I really would like to visit you in the Azores at some point.
I will contact you soon about that.
Yeah, I will love to. I would love to do that. So with that, I would like to again thank you guys for what you have done.
Jose, only one last comment. I want to congratulate IEHSC for his new position as our editor of the newsletter of IMGA.
Congratulations. Welcome. Yes.
Congratulations.
Thank you, everyone. It is a very responsible role.
Well, this is one of those presentations that you will be highlighted on your first newsletter issue for IMGA.
Definitely.
That's great. So great, IEHSC. Thank you so much. And I would like to also thank Jesus for taking over the responsibility of this seminar series and for an excellent technical work that he has done for both the IMGA and the consortium. So thank you, Jesus.
Thank you.
And for my part, finally, I would like to wish everyone happy holidays, okay? Happy New Year to everyone. Please stay safe. This pandemic has taught us a lot of things that we didn't know before, but now I think that we are much better prepared. I think that we will be coming through all these problems, and that all depends for us to stay safe. So thank you so much, everyone. And Happy New Year to everyone. And I see you guys back again in 2022 during the next seminar series, which will be sometime in February, and it will be by Claire Howard from the University of Durham. So thank you so much.
Thank you,
Bye.
dear Jose.
Thank you for hearing
Thank you.
us. And
Merry Christmas.
Bye.
Bye-bye,
Nice-
guys. Bye-bye.